Welcome to Out and About. This one is called Andrew's Workshop and His Drawer of Shame. Believe it or not, Andrew is not a professional engineer, and the quality of his machining is outstanding. Personally, I would not even attempt a job like this. It's a 4-cylinder, 4-stroke glow plug engine. And as with most internal combustion engines, all of the parts have to be extremely accurate. If I expand the shot, you can see the volume of components required to make this engine. Just looking at this makes me feel ill. Before I go any further, these are not CNC manufactured components, they're made by hand. They are made using machine tools that are manually operated. Andrew has a YouTube channel called Model Engineering Adventures, and it's quite interesting. Andrew is not a time-served professional engineer and hasn't been a model engineer for very long at all. Andrew's YouTube channel is definitely worth a look. Have a closer look at what he's making here. A 4-cylinder. It's a 4-stroke internal combustion engine with 4 cylinders, and to make it look right, every cylinder has to look identical. Andrew also cuts his own gears. The gears on this engine are not commercially bought items. And the crankshaft inside this engine, which I will show again later, is a work of art, if you analyse how it's made and how it fits together. When I arrived at Andrew's workshop the other day, he was making a tool which has a number 3 Morse taper, and here he's actually turning the taper in his lathe. This is a very good quality lathe. It's a Myford Connoisseur, and in this clip you can see a jig that Andrew made, which is to offset the tailstock. You have to do this to turn long tapers in a lathe. I was very impressed with this electronic box of tricks that Andrew was using.
Is it reading 0?
No.
Is it nearest damn it?
0.06.
I think that's close enough, don't you?
Yeah, I think so. This is such a useful tool. I've just ordered one and it should arrive tomorrow. It's called a Neotech level box. A very useful device with a variety of applications in the workshop.
I use 34 tooth, M14 is 2mm, which is the same as the spindle on the nose.
Andrew's explained to me at this stage that if he fits this gear into the primary drive chain from the headstock to the gearbox, he will be able to cut metric threads. Let's have a quick look around the workshop. Here's the main lathe that Andrew uses, the Myford Super 7 Connoisseur. Very good quality, not cheap, but it's not the only option open to you if you want to do jobs like Andrew's doing. As long as the machine that you're using has a screw cutting facility like a gearbox and is accurate, then there shouldn't be a problem. But this is a really nice machine. I must admit, I'm sort of tempted to buy one, but no, I have enough lathes. I really am not a good machinist, and I have 3 lathes just to speed up the setup time between them. Before Andrew bought the Connoisseur lathe, he had this, and he still has it. It's a Myford ML7. I think the time has come to show Andrew's collection of really useful gadgets. This is something that he made, and I never thought to make one of these. I actually have a scroll saw that I could modify. Instead of this reciprocating scroll saw having a blade, it's fitted with a needle file. I can think of a lot of model engineering jobs that would suddenly become a lot easier using one of these. This is Andrew's milling machine, and it's a good quality machine. I have to confess, it's not the best one I've ever seen, but it's very good. My milling machine is nowhere near this, and once again I'm very tempted to buy one of these machines because I like them. Andrew showed me this and I really couldn't think what it was. At first I thought, is it something to do with keeping the score in a game of billiards? But no. It has 2 magnets fitted in the back of it, and what it's used for is holding pieces of metal at various different angles. The holes are not randomly positioned. They're carefully planned. This I think he built from a kit or a plan. Picture paints 1,000 words, so I'll show it in action. You should figure out how it works. Andrew's using a coil spring to hold the piece of metal against the block, and once again he's using the Neotech level box to tell him what the angle is. It's worth mentioning before any experts write in that this machine vise is sat on a bar stool, so it's not particularly level. Andrew is moving the machine vise by hand and the display on the level box is now reading 0, so it's calibrated. This is a gadget that Andrew made. What is it? I wondered that myself. It looks like a tailstock die holder, but it's a tailstock die holder with a difference. It has a clutch built in. A taper cone clutch. So when the die gets to the end of its travel, it stops rotating. And as you move the handle the other way, a second taper cone clutch makes it possible to unscrew the die from the work. Very simple and very clever. But not quite as clever as this. Andrew didn't make this as a commercial item and it was not cheap. Once a machine is fitted into the milling machine's collet, with the spindle rotating, you wind the handles until the needle stops moving, and this tells you when the hole is exactly in the centre. It takes a bit of practice to get it right. It's very much like using an old Etch-a-Sketch drawing machine. The next interesting item is simpler than you think. It's 3D printed. This is for a Myford and it's a device to lock the headstock gears when you're removing or fitting chucks. I've mentioned before in quite a few of my videos that when I first started I always had to make 3 of everything until I got one right. And when I first met Andrew a few weeks ago, I mentioned this to him. He smiled and said, "Well, take a look at this lot." And now it's time for the drawer of shame.
What I did in the end is I ended up making 4 of these together out of a plate and machine them all at the same time. And I hate phosphor bronze.
Yeah, the red stuff's horrible. The leaded stuff's nice. And I thought it was bad enough making 3 of everything. This is an exercise in patience. Have a look inside the drawer. Just as I was about to film the contents of the drawer, Andrew tried to defend his incompetence by showing me this, a bit of successful lathe screw cutting. But it was all to no avail. Have a look at these parts. This is a crankcase for the 4-cylinder engine that Andrew's currently making. The second one he made looks like this. I think that the next part must have jumped out of the chuck because it's a bit mangled. Yeah, I know where I can see what that is.
Maybe if I just pick them up.
What went wrong with that one?
Thread stripped.
Yeah.
On the glow plug. This and this and this, those 3 are off the single cylinder.
This is a single cylinder rotary valve glow plug engine, and I'm hoping that Andrew and I can collaborate to try and get this to run.
Stainless steel, copper.
Looking at this, I think I can safely say that silver soldering is not Andrew's forte. I think he needs to watch one of my silver soldering videos. That's the worst of the thing I've ever seen in my life.
Yeah, I think it's coming apart actually.
Yeah, it is. So what's wrong with that?
It's a banana.
Oh dear. It's a very attractive banana. So what did he do? He made another one, and the current one that's fitted to the engine exactly like this, except straight, rotates beautifully. To finish this video, I'm going to make a slight comparison between Andrew's workmanship and what can be achieved if you don't do the job right. This is a diabolical steam engine that I've just rebuilt for a friend of mine. It is not exactly built to the same standard as the models that Andrew builds. I would like to thank Andrew for letting me into his inner sanctum to see how the job should really be done. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.